Good morning, Prof. I appreciate the opportunity to present the group assignment of the core course for the Bachelor of Science with Honors Decision Science program. Course SQQP 1023, Group B, Linear and Nonlinear Optimization, Group 9. Next, I'm going to introduce our group members. First, my name is Chi with matrix number 293600. My team members include Lim En Sing with matrix number 293612. Our next group member is Ong Lu Qian with matrix number 294044. And our last group member is Chong En Qi with matrix number 292648. The topic of this group assignment is linear programming applications. During this video, we are going to talk about the three main aspects of this topic. First, we will explain the linear programming and standard form. Secondly, we will explain the situation that we met, and lastly, we will introduce the Excel solver and show how we use the Excel solver to solve this situation.
In the first and second chapter of this course, we have learned about linear programming and standard form. Linear programming is a mathematical modular technique in which a linear function is maximized or minimized when subject to various constraints. However, in most real-life linear programming problems, we usually have more than two variables and are thus too large for the simple graphical solution procedure. Hence, we need a more powerful method than graphic. In order to solve more complicated problems, we have to change linear programming form to standard form before we start to solve it. Basically, standard form is the same as linear programming form, but standard form is more powerful and doesn't have too much room to solve it. With the purpose of finding the solution more efficiently, we use a solver in Excel to solve it. Excel includes a tool called solver uses techniques from the operational research to find optimum solution for all kinds of vision problems.
The situation we face is to maximize the investment. There is an investor who has $70,000 divided among several instruments. The municipal bonds have an 8.5% returns, CDs have an 5% returns, T-bills have an 6.5% returns, and growth stock has 13% return. Some properties provide which are no more than 20% in municipal bonds. Investment in CD should not exceed the other three alternatives. At least 30% invested in treasury bills and CDs. Then, more should be invested in CDs and treasury bills than in municipal bonds and growth stocks by a ratio of 1.2 to 1, and all 70% $70,000 should be invested. Let's assume that X1 equal to amount dollars invested in municipal bonds. X2 is equal to amount dollars invested in certificates of deposit. Then X3 is equal to amount dollars invested in treasury bills. And the last one is X4 equal to the amount dollars invested in growth stock fund.
There are three main steps to utilize the solver, which is load the solver add-in, formulate the model, and solve the model. Next, I'll introduce how to add the solver in Excel. Firstly, open your Excel app. Create a blank workbook. Open the File tab and click Options. Next, under Add-in, select Excel Add-in and click on Go button. Lastly, select the Solver Add-in and click OK. Now, you may find the solver on the Data tab in the Analyze group.
Next, let me introduce how to use the solver in Excel. For step 1, go to Data in the Excel ribbon and click Solver in the Analyst group. Then it opens a solver parameters window and we enter all the values needed for the below parameters in the solver window. Then we must key in objective function which is cell B17 and maximum. Similarly, at the by changing variable cell, we must key in decision variable which is cell B13 until B16. Secondly, click on Add button to add model constraints. At the subject to the constraint, we must enter all the guidelines constraints. Then, the first constraint is cell I10 equal to cell H10, and the formula is C6 times B13 plus D6 times B14 plus E6 times B15 plus F6 times B16 smaller and equal to 14,000. Next, the second constraint is cell I6 is smaller and equal to cell H6. The formula is C7 times B13 plus D7 times B14 plus E7 times B15 plus F7 times B16 smaller and equal to 0. The third constraint is cell I7 is smaller and equal to H7. The formula is Cx times B13 plus Dx times B14 plus Ex times B15 plus Fx times B16 greater and equal to 21,000. Fourth constraint is cell Ix is greater and equal to Hx. The formula is C9 times B13 plus D9 times B14 plus E9 times B15 plus F9 times B16 greater and equal to 0. Finally, the last constraint is cell I9 is greater and equal to H9. The formula is C10 times B13 plus D10 times B14 plus E10 times B15 plus F10 times B16 equal to 0. Lastly, we go on to solve the model. Click Solve and a solver result window pop up with two options, which are Keep Solver Solution and Restore Original Values. Click Keep Solver Solution if you are satisfied with the optimized values that solver produced, and to load the values in Excel. Or click Restore Original Values if you are unsatisfied with the new values, and click OK. Other than that, we can see the column usage formula is based on the guideline constraints. At the column leftover, we can see the value is represent the unused resources from any constraints. And we can see the column leftover is just the formula is get column available minus column usage. However, for the cell B13 until B16 is represent the decision variables for the municipal bonds, CDs, T-bills, and growth stock, which is X1, X2, X3, and X4. Therefore, cell B17 is the objective function which is the maximized total return. The formula is C4 times B13 plus D4 times B14 plus E4 times B15 plus F4 times B16.
Before the end of the presentation, I'd like to make a conclusion for our project. We have found out the investor should invested $38181.82 in T-bills and $31818.18 in growth stock in order to get the maximum total return of $6618.18. In addition, we can see that the heading leftover has select resources for first constraint and second constraint of S1 equal to $14,000 and S2 is equal to $70,000. It means that each select variable represents an unusual resource. Apart from that, the heading leftover has surplus resources for the third constraint of S3 equal to $17,181.82. It refers to the amount of unused resources that cause the left side of the mentioned equation to be greater than the required minimum. That's all from the group 9. Thank you for watching.